Hi everyone and welcome to today's Saturday session with ExamRevision. Today we're going to look at some trigonometry exam questions from past exam papers. So before we get started into some exam paper questions, let's just look at some important formulas that are relevant to the trigonometry section in our course that are on page 16 of our formula booklets. These formulas are only relevant if we are working with a right-angled triangle. So to use these formulas, we must know that there is a right angle in the triangle that we are working with. Our first formulas are our trig ratios, sine, cos, and tan. Our trig ratios are working with the angle A in our diagram, and that is why we have sine A, cos A, and tan A. So our formulas tell us that sine of A is equals to the side A over the side C. Cos of angle A is equals to side B over side C. And finally, tan of A is equals to side A over side B. Now, in class, you might have learned that these sides were the opposite side, the hypotenuse side, or the adjacent side. If we are working with angle A, our opposite side is going to be the side that's directly across from the angle that we're talking about. Our hypotenuse side is directly across from the right angle in our triangle. And finally, our adjacent side is the third side that's left over, and that side is attached onto the angle that we're talking about. These three trig ratios allow us to find unknown sides or unknown angles in our right angle triangle, and it depends on what information is given to you in the question whether you can use these or whether you're finding a side or an angle by using these. Our next formula is our Pythagoras theorem formula. This formula allows us to find an unknown side in a right angle triangle. To use this formula, we need to know at least two sides in the right angle triangle. It's also very important to remember that your C value in this formula must be your hypotenuse. That is the side that's directly across from the right angle in your triangle. Okay, so looking at our first question from the 2023 paper, it says that a plane P took off from an airport. It left the ground at point T. After a few minutes, it was 7.5 kilometers from T, and it was 200 meters directly above level ground, as shown in the diagram below. Use trigonometry to work out the size of the angle marked E in the diagram and give your answer in degrees to correct to one decimal place. Okay, so a few important things to point out in this question. They helped us out by telling us that we had to use trigonometry. They also indicate in our diagram that we're working with a right angle triangle. The next thing that I would focus on is they've asked us to find a missing angle. That means that we do not need to use Pythagoras' theorem, as Pythagoras' theorem allows us only to find a missing side. Therefore, I must have to use one of my trig ratios to solve for the missing angle E. So the first thing I'm going to do here is I'm going to look and see which of my sides is my hypotenuse, my opposite and adjacent side. Then I can decide which trig ratio is best for me to use. So focusing on angle E, as that's what we want to find, I know that the side directly opposite my angle is my opposite side. Next, I know the side that is directly opposite my right angle is my hypotenuse side. And my third side then is my adjacent. So I can see from what I've highlighted there that I know what my opposite side is and I know what my hypotenuse side is in this right angle. And from my formula booklet, I know that the sine ratio uses the ratio opposite over hypotenuse. Therefore, I am going to use the ratio sine to figure out the angle E. So setting up my equation, sine of angle E is equals to my opposite side, which is 200 meters, over my hypotenuse side, which is 7.5 kilometers. Now, I have a problem here with my fraction on the right-hand side of my equation. I have 200 meters over 7.5 kilometers, so I'm working with two different units. Therefore, I must change them to be the same unit. So I'm going to change 7.5 kilometers into meters, and if 1 kilometer gives me 1,000 meters, That means 7.5 kilometers will give me 7,500 meters. So I'm going to change my equation to sine of E is equals to 200 meters over 7,500 meters. Now I can begin to work to isolate my angle E. To isolate my angle E, I am going to sine inverse sine of angle E, which would cancel out my sine, but I must do the exact same to the other side. So I'm going to sine inverse 200 over 7,500. That will cancel out the sine, and I will be left with angle E here, and then I can pop into my calculator sine inverse of 200 over 7,500. That gives me a value of 1.5281 degrees. The question asked me to round my answer to one decimal place, so I will say that angle E is equals to 1.5 degrees. So that tells me that as the plane took off from point T and went to point P, it went at an angle of 1.5 degrees. Moving on from this question, it says in the diagram below, each of the points A, B and C represents an airport. The plane travelled 598 kilometres from airport A to airport B and then travelled on to airport C. Work out the distance AC correct to the nearest kilometre. So from our diagram here, we can see that we have two right angle triangles. The first one highlighted here in blue, and our second highlighted here in yellow. I can work with these two right angles separately to give me the full distance from A to C. Firstly, I can work with my blue right angle triangle to give me the distance from A to this point here. And then I can use my second right angle triangle, the yellow right angle triangle, to find the distance from C to that point here. And adding both of those lengths together will give me the distance between A to C. So working with my first right angle triangle here, I know that one side is equals to 280 kilometers and one other side is equals to 598 kilometers. And I want to find out the length of this third side here. Now, because it's a right angle triangle and I know two sides, I can use Pythagoras' theorem to find a third side. Therefore, I'm going to write down what Pythagoras' theorem is first from my formula booklet, which is c squared equals a squared plus b squared. From that formula, it tells us that c must be my hypotenuse value. So I'm going to figure out which is my hypotenuse from my right angle triangle. And I can figure that out by looking at my right angle from the triangle and looking at the opposite side, which in this case is 598. So I know that my value for C must be equals to 598. Next, my values for A and B come from the other two sides of my triangle. It doesn't make a difference which you pick as A or B, so we can pick 280 as A, and then B is going to be my unknown side. So inputting that into my formula, it will give me 598 all to be squared is equals to A 280 to be squared plus B to be squared, which we don't know yet. Now I'm going to use algebra to get B isolated by itself and work out what the value of that length in my right angle triangle is. So before I start moving things from left to right, I'm going to work out what 598 to be squared is, which is 357,604. 280 to be squared is 78,400 plus b to be squared. Now I can begin to isolate b by itself. So firstly, I'm going to remove 78,400 from the right hand side by subtracting it, which means I must subtract it from the other side. That then just leaves me with b squared on my right hand side and 279,204 on my left hand side. Then to get b by itself, I'm going to do the square root of b squared, which I must also do on my left hand side. That will then give me a value of b is equals to the square root of 279,204, which is 528.4 kilometres. So that's the first part of my question. I now know that the length of this missing side in the first right angle triangle is 528.4 kilometres. In the second part of my question, I'm going to use my second right angle triangle. In this right angle triangle, I know one side and I know one angle. Therefore, unlike my first right angle triangle, I cannot use Pythagoras' theorem as I do not have enough sides to use that formula. Therefore, I must have to use one of my trig ratios. To decide what trig ratio I'm going to use, I'm going to decide which is my opposite, hypotenuse and adjacent side. Focusing on the angle of 35, I can see my opposite side is equals to 280. The right angle is here, so my hypotenuse side is this side here, which means that the side that I want to figure out is my adjacent side. So here I know what my opposite side is and I want to find out what my adjacent side is. Therefore, the trig ratio that I want to work with is tan. So building up my equation, it will be tan of the angle I'm working with, which is 35 degrees, is equals to my opposite side, which is 280 kilometres, over my adjacent side, which I don't know. So I'll just label the adjacent side as A. So now I'm going to use algebra to get A by itself so I can figure out what that length is in my right angle triangle. So working out ratios where you don't know what the denominator of the fraction is, I would always tell my students to remove the fraction first. So we can see that 280 is being divided by A here. So to remove the A from being a fraction, I'm going to multiply by A on the right hand side. That means that I need to multiply by A on my left hand side also. That will cancel out the A's on the right, and I will now be left with A multiplied by tan of 35 degrees is equals to 280. Now I have no fractions left. My A is on the left hand side, but it's attached by multiplication with tan of 35. So to remove tan of 35 from the left hand side, I'm going to divide by tan of 35. And I must do that on my right hand side too. That will cancel out the tan of 35s on my left, and it'll leave me with A is equals to 280 over tan of 35 degrees. Now I can pop that right hand side into my calculator and I get an answer of 399.88 kilometres. So this is now my second value for the unknown side here. That is equals to 399.88 kilometres. So for me to get the full value of the length of AC, I'm going to add my first answer that I got from my first right angle triangle, 528.4, plus the answer that I got from my second right angle, 399.88. Those are the two values that make up the full length of AC. And that gives me an answer of 928.28 kilometres. Now the question asked me to give my answer to the nearest kilometre, so I'm going to round my answer. The length of airport A to airport C is 928 kilometres. And that's my final answer for that question. Our next trigonometry question from this paper tells us that the diagram below shows a triangle ABC. The point D and E lie on the line segment AC and BC respectively, and that the angle CAB is equals to the angle DEC, which are both 90 degrees or right angles. The lengths of some of the sides are given in the diagram. Work out the value of x. So we can see that x appears twice in our diagram. It appears here and here. For me to figure out x, I'm going to work with this right angle here. That is a right angle triangle where I already know two sides of the right angle triangle. This allows me to use Pythagoras' theorem, which means that I can figure out the value of x. So again, writing down what Pythagoras' theorem is from our formula, it's c squared equals a squared plus b squared. I'm then going to highlight what each side of my triangle is. This is my right angle here, so that means that 15 represents my hypotenuse, or in this case, my c value in my Pythagoras' theorem. A and B then can be the other two sides. It doesn't make a difference which one you place as A or B. So I'll place 9 as A, and B I will keep as x, my unknown value that I want to find. Subbing that into my Pythagoras' theorem then will give me 15 squared is equals to 9 squared plus x to be squared. I'm now going to square out those values. 15 squared is 225, which is equals to 9 squared, which is 81, plus x to be squared. My goal now is to get x by itself on one side of the equation, so I'm going to remove the 81 first by subtracting it from both sides. That then gives me 144 is equals to x squared. Then to remove the square from the x, I'm going to square root, and I must do that to both sides. The square root of x squared is x, and the square root of 144 is 12, meaning that the value of x in this diagram is equals to 12. This question continues then in part B and says, using similar triangles, work out the value of y. So we've already figured out from the previous question that x is equals to 12. So firstly, I'm going to change my x values in the diagram to 12. The question has told me to use similar triangles to work out the value of y. Therefore, we need to figure out which triangles are similar here. My first triangle that I'm going to work with is the big triangle going from A to B to C. I'm going to rewrite that triangle down here just to make it clear in this question. So we've got A at my right angle, then we've got B and C. I will then just input some values that I already know from this triangle. I know that the length from A to B is y, and the length from B to C is 24. The next triangle that I'm going to work with is the triangle D to E to C. And again, I'm going to rewrite this triangle down here. My right angle again, I know that that's point E, then over to D, and then to C. And again, putting in the lengths I know the length from E to D is 9, E to C is 12, and C to D is 15. Now, these triangles are similar triangles because they share the exact same angles. They've got a right angle here together. They share a common angle up here, which means that their third angle must also be the same. So they have three of the same angles, which makes them similar triangles. And when we have similar triangles, we can create ratios and put them equal to each other. So I want to find out what is the missing side here, AB, which is valued y. That is corresponding to the 9 over here. Likewise, I know that this side is 24 here, which is corresponding to the side that is 15 here. So creating a ratio there with those similar sides in my triangles, I can put y over 9 is equals to 24 over 15. Now to get y by itself, I'm going to multiply both sides by 9. And that will cancel out my 9's on the left hand side, giving me y is equals to 24 over 15 times 9, which when I put into my calculator, it gives me a value of 14.4. So that tells me that the distance from A to B, or the side that's named y, is equals to 14.4. So with this question, always a good idea that if you're using similar triangles to draw the triangles out separately yourself, just so you can see which sides are corresponding to each other. It's a lot easier to see it when you have them drawn out separately than when you look in the diagram that they've given you in the question. Next, moving on to the exam paper from 2022. The first question we have here tells that a diagram below shows two vertical buildings A and B. Mary stands on the top of building A and she is 220 metres above the ground. She wants to work out the distance marked Y and Z in the diagram. That is the distance between the top of building A and the bottom of building B, and the height of building B respectively. Mary measures the two angles that are marked 35 degrees and 20 degrees in the diagram, to the bottom of building B and to the top of building B respectively. The broken line is a horizontal line. So the first part of this question asks us to work out the size of angle C. So this uses our geometry formula, as we know that this line here is the ground, which means it must be horizontal. And this dotted line here, they told us in the question, was also a horizontal line as well. That means that both these lines are parallel to each other. And if we can create a Z with the transversal line between two parallel lines, we create alternate angles. That means that the angles trapped in between my Z here and here are equal in measurement. I can find out the measurement of this angle here, as I know that the full angle is equals to 90 degrees. Therefore, the angle that I've highlighted in red there will be 90 degrees minus 35 degrees, which gives me an answer of 55 degrees. That means that this angle here is 55 degrees, and since this angle is an alternate angle with angle C is also 55 degrees. Therefore, my answer for this question is the size of angle C is 55 degrees. Now, another way of doing this question is you could have noticed that this was a right angle triangle here. So you knew one angle down here was equals to 90 degrees. And you also knew that another angle was 35 degrees. We should also know from geometry that each triangle has three angles that add up to 180 degrees. So we can find out what angle C is by doing 180 degrees minus my right angle 90 degrees minus my second angle that I knew 35 degrees, which again gives me C is equals to 55 degrees. So with these questions, there might be multiple different ways to do them. So whatever way you want to do them yourself or whatever way you figure out to be the easiest way for you, go with that. Okay, so just looking at the marking scheme for this question, we can see it was worth 10 marks, which is quite generous for this question. We can see again, there's multiple different ways that you can do it. Already showed you that in the previous slide. So there you were getting 10 marks for getting 55 degrees out. Again, partial credit worth 4 marks here. Okay, so basically if you did any correct work there, maybe mentioned 180 or 90 plus 35, or you could have used one of your trig ratios like we did as well. Okay, but failed to finish the question out there. So lots of marks going there for that question. The next part of this question says that Mary works out the horizontal distance between the two buildings is 154 metres, and that's marked here in our diagram. Correct the nearest metre. Use the theorem of Pythagoras to work out the distance marked y on our diagram and give your answer to the nearest metre. So they tell us here to use the theorem of Pythagoras. So straight away I'm going to get down what that theorem is. C squared equals a squared plus b squared. Next I'm going to highlight in my right angle triangle which side is going to be A, B and C. So as I've told you previously, the most important side is your C value, which is your hypotenuse. And in this case, my right angle is here, so that means my hypotenuse is equals to y. So C is going to be equals to my unknown variable that I want to find, y. A and B then are my other two sides of the right angle triangle, which can be 154 and 220. I'm now going to input those into my Pythagoras' theorem as y to be squared for C, a to be squared, which is 154 to be squared, plus b, which is 220 to be squared. Working out those squares there in my calculator, y squared is equals to 154 to be squared, which is 23,716, plus 220 to be squared, which is 48,400. I'll then add those two numbers together on my right hand side, which gives me a value of 72,116. Finally, to get y by itself, I'm going to square root y squared, which means I need to square root my right hand side. That then gives me that y is equals to the square root of 72,116, which is 268.54 meters. Now the question again asked me to round it to the nearest whole metre. So looking at my number after my decimal place is 5. That is going to make the 8 round up to 9. So that will give me a value of y is equals to 269 metres. And that is my value for y in the diagram there. So again, looking at the marking scheme for this question, it was worth 10 again. So the same as part A, but there was a bit more work involved in this. Again, separated into low partial, which was worth 4. And then you had your high partial, which was worth 7. So low partial there, if you were able to write the correct formula and just sub in any of the correct values, they were going to give you marks for that. And then moving on to the high partial, if you were able to square any of your terms, and also an interesting point there, correct answer without any work. So really important to show your work as you're doing these questions, that you're writing down Pythagoras' theorem, subbing in your values correctly, and then multiplying out as you go down, moving things over to the correct side of the equation. And again, as we've seen before, minusing 1 there if you failed to round or you didn't round up correctly. So important, take your time there at the end to make sure that you're rounding it to the nearest whole number if that's what's asked. The last part of this question asked me to use trigonometry to work out the value of z, the height of building B, and give your answer correct to the nearest metre. So we can see that z is going from the ground all the way up to the very top of building B. Well, we know already from building A that up as far as building A is a height of 220 metres. So we know that z goes up as far as 220 metres to that point there. We need to find out what is the remaining height of building B up here. So I'm going to use my right angle triangle that I have here to do that. In this right angle triangle, I already know that we have one angle that is 20 degrees. I know that the distance between the two buildings is 154 metres. Therefore, I know an angle and a side, which means I can use one of my trig ratios. So focusing on angle 20, the side that I want to find out is my opposite side. My hypotenuse side across from my right angle is unknown. I don't want to find that out. And finally, my adjacent side is the distance between the buildings, 154 metres. Therefore, I'm using my opposite and adjacent sides as I want to find out the opposite side and I know the adjacent side. That means that I'm going to use the trig ratio tan, as tan is equals to my opposite over my adjacent. So building that equation with my angle 20 degrees, it will be tan of 20 degrees gives me my opposite side, which I don't know, so I'll keep that as O, over my adjacent side, which is 154. Now I want to isolate the O by itself, so I'm going to remove 154. 154 is attached onto O by division, so to remove it, I'm going to multiply the right-hand side by 154, which means I also must multiply the left-hand side by 154. That will cancel out 154 on the right-hand side, leaving me with 154 times tan of 20 degrees gives me my opposite side. So popping my left-hand side into my calculator, 154 times tan of 20 gives me 56.05 metres is the length of my opposite side here. So this length from this red part in the building B up as far as the top is 56.05 metres. So the total height of building B will be the original height that we knew, 220 metres plus 56.05 metres. And adding both of those numbers together, we get 276.05 metres. Again, the question asked me to round to the nearest metre, so looking at 276, the 0 after the decimal point will keep that as 276 metres. So my final answer for the height of building B is 276. In the final part of this question, it was only worth 5 marks, so worth the least marks out of all of the 3 parts in this question, and probably one of the toughest of the 3 questions. So here they separated into low, mid and partial credit. So low was giving you 2 marks, mid partial was giving you 3, and then finally high partial was giving you 4 out of the 5 marks. Okay, so they kind of based this off 3 steps here, that if you were able to set up the equation correctly, if you're able to evaluate h in the equation or evaluate z in the equation, they use different letters than I did, but they use the exact same method that I did. So again, there for low, if you were setting up the correct equation there, you used tan, okay, or you were able to build what tan was, you would have got some low. Then mid, 1 of the 3 steps correct, and then high, then 2 of the steps correct. Again, looking for what they were taking away 1 mark for at the end, rounding again or incorrect rounding, and then just saying if your calculator wasn't in the correct mode. So your calculator should always be in degrees. You see a top, the top part of your calculator should have a D on it always, okay, to make sure that you're getting the correct answer. We're working in degrees always in junior cycle. Our next question comes from the SEC sample paper. It tells us that a photograph on the right shows a house. Part of the roof of this house is shown in the diagram below. AB is perpendicular to the line DC, where the length of AD is 11.8 metres, the length of DB is 2 metres, the angle CAD is 20 degrees, and the angle DBC is X degrees. And it also tells us to note that ACB is not a right angle triangle. So they're telling us that up here, this angle here is not a right angle. It then goes on to say to use trigonometry to work out the value of x and give your answer correct to the nearest whole number. So like what we've seen previously, we've got 2 right angles going on here. We've got a first one here going from A, C and D. And then secondly, we have another one going from C, D, B. We're going to have to use these 2 right angles to eventually get what the size of the angle x is. So I can't just work out what the angle x is, because if I look at this right angle here, I only know that one side length is 2 metres. I don't know any angles other than this is a right angle, and I don't know any of my other 2 sides, h or my hypotenuse side. So I'm really stuck with that right angle. So I must use the other right angle to get some more information about that blue right angle that I've highlighted there. So focusing on the right angle ACD, I know that one angle is 20 degrees and I know that one side length is 11.8. This will allow me to find the side H. Okay, and I can do this by using my trig ratios. So focusing on angle 20, I know that my hypotenuse side is across from my right angle. My opposite side is across from the angle I'm talking about, which is H. And my adjacent side is 11.8, my third side. So I know if I want to find H, I have to use my opposite side. I already know what my adjacent side is, and I know that my trig ratio for opposite and adjacent is tan. So tan is equals to my opposite over my adjacent. So now I can build my equation saying that tan of my angle 20 is equals to my opposite side, which is H, over my adjacent side, 11.8. And I'm going to use algebra to try and get H by itself. So first I'm going to remove 11.8, which I'm dividing into H. So I'm going to multiply the left-hand side by 11.8, and I'll do that on both sides. That will once again cancel out 11.8 on the right-hand side, leaving me with 11.8 multiplied by tan of 20 degrees is equals to H. Popping that left-hand side into my calculator, 11.8 times tan of 20 gives me 4.295, which is the length of H. I now know what H is, and this will now allow me to go and figure out what angle X is. So with H being equals to 4.295, I can now focus on my other right angle, triangle CDB. My angle X is here, and I know 2 sides, 4.9 or 4.295, and the side length DB, which is 2. Again, I can use a trig ratio here to find the missing angle x. So focusing on what side is which, my right angle is here, which means my hypotenuse side is the side CB. My opposite side of angle x is my 4.295. And my third side, my adjacent side, is DB, which is 2. So here I know two sides, my opposite and my adjacent. Again, this is the trig ratio, tan. So building that equation, I can say tan of my angle, which is x degrees, is equals to my opposite, which is 4.295, over my adjacent, which is 2. Here, to get x by itself, I need to remove the tan. So I'm going to multiply that by tan inverse. And I must do the same on the right-hand side. That will cancel out the tan on my left-hand side. So that will leave me with x degrees is equals to tan inverse of 4.295 over 2. I'm popping that into my calculator, so to get tan inverse, I'm pressing shift and then tan 4.295 all over 2 gives me 65.03 degrees. The question asks me to round this to the nearest whole number. So I'm going to say that x is equals to 65 degrees. And that's my missing value there for x. Our final question comes from the SEC sample paper. It says, in this diagram below, the length of each of the sides is given in terms of x, where x is a natural number. Show that there is only one value of x for which the triangle is a right angle triangle. Now in this question they don't tell us what angle is the right angle, but we can assume that this will be the right angle. Now I know that this is the right angle because all of my sides have x in them. And x must be the same value. So x plus 4 must be the biggest side because it's the only side where you're adding on a number to x. The other two is x minus 5 and x minus 4, which means that x plus 4 must be the largest side. And we know that the hypotenuse will always be the largest side. Therefore, my right angle and my hypotenuse are opposite each other here, which means my right angle must be there and my hypotenuse must be x plus 4. Now, since this is a right angle triangle, I can use Pythagoras' theorem and substitute in my values for the three sides here. I should be able to work out that equation then to get a value of x. This question here is a mixture of algebra but also applying Pythagoras' theorem from the trigonometry chapter. So again, I'm going to write down what Pythagoras' theorem is. It's c squared equals a squared plus b squared. Now, I already said that c must be my hypotenuse, and I said that x plus 4 is my hypotenuse in this question. A can be one of the other two sides, I'll put it as x minus 5, and b will be the third side, x minus 4. I will now fill this in very carefully into my formula. So remember that everything for a, b, and c must be squared. So c is x plus 4, so it's x plus 4 to be squared, is equals to a to be squared, which is x minus 5 to be squared, plus xb, which is x minus 4 to be squared. Now, there's going to be a lot of algebraic multiplication in here. So firstly, we're going to expand out our brackets. X plus 4 to be squared means x plus 4 multiplied by x plus 4. X minus 5 to be squared will be x minus 5 times x minus 5. And finally, x plus 4 to be squared will be x minus 4 times x minus 4. Now I'm going to split my first bracket in each and multiply it by the second bracket. So x multiplied by x plus 4. And then my second term in my first bracket plus 4 times x plus 4. Again, I'm going to repeat that step on the right-hand side of my equation. So the first term in my first bracket here is x times my second bracket, x minus 5, and then minus 5 times x minus 5. Again, then for the x minus 4, it's going to be plus x times x minus 4, and then again, I'll just continue on down here, minus 4 times x minus 4. So you can see a lot of multiplication here, so do take your time multiplying out this. Okay, it's very easy to make just a silly mistake somewhere. So now we'll multiply into the brackets. Firstly, x times x gives me x squared. X times plus 4 is plus 4x. Plus 4 times x is plus 4x, and plus 4 times plus 4 is plus 16. Equals to x times x is x squared, x times minus 5 is minus 5x, minus 5 times x is minus 5x, and minus 5 times minus 5 is plus 25. Next, plus x times x is plus x squared, plus x times minus 4 is minus 4x, minus 4 times x is minus 4x, and finally minus 4 times minus 4 gives me plus 16. So that's all my multiplication done. I'm now going to tidy up my like terms on the left hand side first. So plus 4x and plus 4x can be tidied up, and that will give me x squared plus 8x plus 16. On my right hand side, my like terms are x squared and x squared, which is going to give me 2x squared. Then I have minus 5x, which gives me minus 10x, minus 4x, which is minus 14x, minus 4x, which is minus 18x. And then finally, I have plus 25 and plus 16, which gives me plus 41. Okay, so now I can see I've simplified on the left hand side and the right hand side here. So I need to kind of bring everything over to the one side there so I can create my quadratic. As I can see, I have a quadratic on the left and a quadratic on the right, and then I'm going to have to go and solve that quadratic. But first I need to get everything over to one side so I can solve my quadratic. So I'm going to bring everything over to the right hand side. So I'm going to take away x squared from both sides. I'm going to take away 8x from both sides. And finally, I'm going to take away 16 from both sides. And that will end up cancelling everything there on my left-hand side. And tidying up my right-hand side then, 2x squared minus x squared will give me x squared. Minus 18x minus 8x will give me minus 26x. And finally, plus 41 minus 16 will give me plus 25. And that is equals to 0. Okay, so there's my quadratic x squared minus 26x plus 25 equals to 0. I now want to go and solve that and say that that can be my only value for x. So here I'm going to use my guide number method. So picking out what is my guide number here. You might do this the quicker method. I'm going to do it out the guide number. So my first coefficient in front of x squared is 1 times my constant, which is 25. So my guide number is 25. My factors of 25 are 1 times 25 and 5 times 5. Which factor pair there is going to give me my middle term minus 26x? That is going to have to be 1 times 25. So to get minus 26x there, I can do minus 1x minus 25x. So I'm going to replace minus 26x with minus 1x minus 25x. So it'll give me x squared minus 1x minus 25x plus 25. Okay, I'm now going to group those terms then. So I'm going to group my first two and my last two and take out what's common. In my first pair, I have x in common, which leaves me with x minus 1. In my second group, I has a minus 25 in common, and that will leave me with x minus 1. And then so both my brackets are x minus 25 and x minus 1. Now to go and solve those, I'm going to put them both equal to 0. So we've got x minus 25 equals 0 and x minus 1 equals 0. So getting the x by itself, I'm going to add 25 onto both sides here, which gives me x is equals to 25. And finally, if I add 1 on here, that gives me that x is equals to 1. Now you can see I've got two answers for x here, which makes sense. I had a quadratic, but they told me in the question that there should only be one value for x, but I got the values 25 and 1. It would not make sense for my value to be 1, as that would mean that x being 1 here would mean that would be 5. This would be minus 4, and this would be minus 3. It's impossible for us to have negative values for a length there, so my answer has to be 25. So just make that clear there that you're saying, yeah, x is equal to 25 must be my correct answer. And maybe if you want to cross out the second answer there. So my answer to this question is x is equals to 25, and that is my one value to make this a right angle triangle, and we proved that using Pythagoras' theorem. So you can see a lot of multiplication, very easy to make a mistake there. Okay, take your time. Good technique to work on your algebra there before looking at this question, and to make sure at the very end that you just show that there is only one answer. And the reason for that is because it wouldn't make sense for 1 to be my value of x there. It would make that triangle have negative lengths, which is impossible. Okay guys, that's it for today's lesson. I hope you found it useful. We went through a lot of different techniques that you can use in trigonometry. Again, looking at our trig ratios and our Pythagoras theorem popping up quite often in the exam questions. So make sure you are able to work with those. You know that they're only relevant if you're working with right angle triangles. So thanks a million for joining, and we'll see you again soon.